we are going to talk in depth about some new things. Okay, we're gonna have some vocabulary that we need to talk about, and we're going to learn what a radian is and how we use them in Trig. Okay, so first of all, let's talk about angles. Okay, so we're gonna move away from triangles just for today. Okay, and talk only about angles. We'll introduce triangles again tomorrow. All right. So if we have an angle, this right here is called the vertex. I hope you know that from geometry. Okay. Now, when we have an angle, we have a starting point. This is called my initial, and then we have an ending point. This is called my terminal. This is called terminal. And I'm going to use these words a lot today, initial, vertex, and terminal. Probably not vertex so much, okay? So now, if with my initial, I say that I'm going to move this angle this direction, right? And so how many degrees is this? This one is about 40 degrees, okay? All right. So my initial was here. I moved my terminal, and that's what and I got about 40 degrees. Now, let's do another one, because those are the easy ones to identify, okay? I'm just going to label this I and T. All right. Now, with this angle, I'm actually going to do something a little bit different. Okay. I'm going to start here. Okay. But instead of stopping when I get there, I'm going to go around. Okay. Well, guess what? I'm going to go around again. And then I'm going to stop. Now, this is where it gets tricky, right? So I still started in the same place. Okay. I still started in the same place, and I ended in the same place. But I went around. All right. So if you remember correctly, a full circle is 360 degrees. So if I were to add up my angles here, this is actually about 830 degrees. Okay, this is super important because these angles look exactly the same, but this one is 40 degrees and this one is 830. So and we're going to talk about what that means in a little bit about them being the same. Let's talk about a couple more angles. So let's say I start with another angle. This time we're going to go this direction. All right. So this is my initial. This is my terminal, and my angle goes down like this. Okay. Now that is a negative degrees. Okay. We're actually going to be plotting these on the coordinate plane in just a minute. But this is a negative degree. So this is a negative 43 degrees of a triangle. So so that's one way to do it. One other way to talk about initial and terminal, I have one more example of this. Okay. Is again, we're going to go back to this little triangle that looks like this, initial, terminal. But what if I didn't start? What if I started my initial, but I didn't go inside? I went all the way around the outside. Okay. This is also an angle measure. Okay. And this angle measure, it's negative because I went down. So it's negative 312 degrees, about, just depending on how you look at it. So, all right, so this initial and terminal. Okay. Now let's plot these on a coordinate plane. So I'm going to draw a coordinate plane. I meant to get one up here and I forgot. So you'll have to deal with my messy coordinate planes that are not quite perfectly neat. Okay, so let's start with an angle that looks like this. Okay, that goes in this direction. Okay, this is a positive angle. If I were to draw an angle that went this direction, okay, this way, that is a negative angle. All right. So that's just something. You just need to know the positive and negatives. All right. So let's talk about something that's called co-terminal. Now, remember the terminal. The terminology is that it has the same that where it starts and where it ends. So let's draw this triangle one more time. This one, or not triangle, but this. Okay, so this one has 60 degrees as my angle measure. Now let's say that I want to know what are some other degrees that are co-terminal with this. It means that it starts and ends in the same place, but has a different measure. So I could start here and go like this. Okay. So I'm still using the same angle, but it has a different measure. Okay, this measure is This measure is 420. All right. Now let's say that I decide I'm going to use a different one. I'm still going to start and end at the same place, but I'm going to go outside. Right? Okay, remember I went down, so it's negative. This is a negative 300 degrees. Okay. I could do more. I could. Now this is going to be a little confusing because I have too many on there and I don't want to erase the whole thing. But I could start here. Actually, let's just extend the blue one. That'll be the easiest thing. Let's say I started here, right, and I went around once. Let's go around again. Okay. And now I have, make sure I have enough. 780 degrees. Okay. All of these using the exact same angle. Isn't this cool? I think that's really neat. So, alrighty. Moving onward. Now, a lot of this that I'm doing right now is kind of background knowledge to build into what we're going to do. You won't actually have any problems on your homework to do with this type a little bit, but we have to talk about something called radians first. So what we want to talk about is that there's something, and you're going to hate this term by the end of Trig because you will see it so much. It is called a unit circle. Right? Now, a unit circle is drawn on a coordinate plane, and it's perfect. Okay, my circle obviously is not. All right. The coordinates of where it crosses the vertex or the axes. This one is 1, 0. This is 0, 1. This is negative 1, 0, and this is 0, negative 1. So it's a perfect circle. All right. And we are actually going to find angle measures all the way inside this circle. So we're going to find a bunch of them that go like this. But we don't use degrees. We use something called a radian. Now, a radian measures the space of the arc. All right. So there's actually very easy ways to convert between radians and degrees. But let's just talk about what a radian is and how it works first of all. So this is the definition of a radian. So I'm just going to read through this with you really quick, so that you have an understanding of it, of what it is. Okay, I keep forgetting to put my marker on it. Alright, so the radian measure of an angle is the distance traveled along the unit circle in a counterclockwise direction. Alright, so let's talk about what that means. Okay. I have my unit circle. Okay. Traveling in a counterclockwise direction. Alright. By the point P as it moves from its starting point to the initial side and the final position of the terminal side of the angle. So basically, it starts here, right, and ends there. Okay, what's the distance? Okay. So 1 radian is 180 degrees divided by pi, which is about 57.3 degrees. If the vertex of an angle is at the center of the circle of the radius r, then the angle of 1 radian intercepts the arc of the length of r. That's not important. So anyway, so we're going to find all these radians, all right? Radians are important. Like I said, you're going to get sick of hearing about them. They're basically, it's just another way of writing a degree. And they're used in Trig a lot more often than the actual degree measures. So let's talk really quick about, just briefly look at this chart and figure out what it's talking about. Now, radians are typically measured in sense of pi, which is really handy. So in this one, I have 1 revolution. You'll notice, so I start here and I go all the way around. That is 2 pi. Okay, that's important. You need to remember that. Okay, 360 degrees is 2 pi. Now you'll notice this one, I went 3/4 of the way. The second one, I went 3/4 of the way around. Okay, that's 3 pi over 2. Okay, if I were going to go just half the circle, okay, full circle is 2 pi, half the circle is pi, right? And 1/4 of the degree, a quarter way up is pi over 2. Again, you will memorize these. I'm going to give you a unit circle paper at some point, and you'll probably have a quiz, your first major quiz over all of this. I will give you a unit circle, and you will have to fill it in completely. So I know I don't make you memorize things very often, but this one will be important. So let's talk about how we can convert degrees to radians. So if I'm going to start with, if I want to go from degrees to radians, okay, this is just calculator work, really not that hard. Okay. I'm going to multiply by by pi over 180. If I'm going from radians, which we don't do this very often, but every once in a while, to degrees, I'm going to multiply by 180 over pi. Okay, it's just the opposite. So let's do a few examples. So let's say if I have, let's convert to degrees first. Let's say I have pi over 5, okay? And I want to know what that is in degrees. So I'm going to multiply by 180 over pi, and that's going to give me 36 degrees. Now, let's say I want to do 4 pi over 9. Okay, I'm going to multiply again by 180 over pi, and that gives me 80 degrees. Calculator stuff, seriously, use your calculators to do these. The next one, I'm going to convert degrees to radians. So if I have 75 and I want to go to radians, I multiply by pi over 180, okay? Please leave them in pi form, okay? Which means that your answer, when you do this, 75 pi over 180, I don't want it in decimal form. I want you to simplify the fraction, okay? If you just need to put 75 over 180 in your calculator to get the simplified fraction, please do that. So this is 5 pi over 12. Okay. Let's do this one, 220, okay, times pi over 180. Again, it's going to be 220 pi over 180. And that's going to equal, if I simplify that, 11 over 9. 11 pi over 9. Okay, pi has to be part of the answer. Okay? So let's look at why we want pi as part of it. Okay, pi is just, it's because it's an irrational number, we can't ever figure out what it is exactly. So when we deal with the unit circle, okay, everything is written in terms of pi. I know the question is going to come up is why do we use radians instead of degrees, and I don't know the answer to that. So I can look it up, but I don't think it's that important other than that, especially as an introduction to trig, that we understand that we're using radians instead of degrees. It's important at this point that you switch your calculators back to radians. I have not found a good way to make the calculator give me answers in terms of pi. I'm still looking at that. So this is a unit circle. You see all those pieces that are marked, okay? 0, 30, 45, 60, 90, 120, 135, 150. I will expect you to know what those are in terms of radians. You will fill out the unit circle. Again, on a quiz, I will fill in the degrees. You will give me, well, I don't know if I'm going to fill in the degrees. But this is a unit circle. You need to know it. So, all right, so how do we use this unit circle? And you're not actually going to use the unit circle too much today, but all coterminal angles can be simplified down into an angle that's on the unit circle. Well, and some of them, obviously, there's angles that are missing, right? We have angles throughout there. But we don't want to have an angle that is outside of the unit circle, meaning like if I had done this, what I really want to know is what's that angle, not the whole thing. So there's ways to figure this out. And most of the time it has to do with the idea of that when we do bigger angles, we're going in multiple circles, okay, bigger circles. So what we want to do is we want to add or subtract 2 pi. 2 pi is 360 degrees to get to the radian measures that we want. So let's say I have negative pi over 3. Now you will notice that none of these degrees are negative, okay? It starts at 0 degrees and goes to 360, so we don't go negative. So we want to find the degree that's actually the positive version of negative pi over 3. So to do this, we are going to actually add 2 pi. All right, and it's this easy. There's a section on your homework that asks you to do these things. You're going to either subtract or add 2 pi until you get a measure that's on the unit circle. And again, it may not be exactly one of them that are on there, but it could be one that's in the middle. It just has to be between 0 and 2 pi. So if I add 2 pi to pi over 3, I end up with 5 pi over 3. Now this one actually is on the unit circle. So negative pi over 3 is the same thing as 300 degrees or 5 pi over 3. So this is one where I add. Now let's look at one where I have to subtract. 19 pi over 4. Right? Now this one, this is a really, really big one. So we're going to look at, I want to know what is 19 over 4? What is that as a decimal? It's 4.75. Okay? So if I want my answer to be between 0 and 2 pi, I'm going to look at this idea that that's a 4. And I'm going to subtract 4 pi. Okay? And the question, why do I do 4 pi instead of 2 pi? Because if I just subtract 2 pi, my number's still going to be bigger than 2 pi. I want it between 0 and 2 pi. The answer must always be between 0 and 2 pi. So, so I'm going to subtract 4 pi. So that's what you just need to kind of look at and judge, you know, what do I need to add or subtract so that the number answer is between 0 and 2 pi. If I just did subtract a 2 pi and still discovered that I needed to subtract another 2 pi, you can do it that way too. But I'm a big fan of let's do it simpler if we can. So that answer then is 3 pi over 4. You will notice 3 pi over 4 is actually on my unit circle. It's 135. So, all right, that's it. Your homework will be out of the pink book once again. There's all kinds of good examples in there if you still need more to look at.